Well, hey there, kiddos. Today we're going to talk about solving systems by elimination, which is one of the three methods that we're going to use. So far, you've solved systems using substitution. That's what we did Friday and again today in class. And then elimination is another way. We're going to spend 2 days on this, and both days are going to be a little bit different. I'm going to add some steps to what you need to do tomorrow, or on tomorrow's video. But we're going to do elimination day 1, and it's pretty basic. Your goal with elimination is to do just that. You want to eliminate something, and what you're wanting to eliminate is one of the variables. You want it to completely cancel out, because what we're going to do is we're going to take our two equations that we're given and we're going to add them together. And when we add them together, we want one of the two variables to completely cancel out. And the only way for that to happen is for them to be complete opposites. They have to have equal coefficients, so the numbers in front must be the same, and then they have to be opposites. One needs to be positive and one needs to be negative. So look at example 1 here. I have x plus 2y equals 5, and then I have negative x plus y equals 4. When I add those together, this x and this negative x will cancel each other out because they have the same coefficient. They both have a 1 in front, and then one is positive and one is negative. Now I'm going to add up everything that's left. 2y plus y makes 3y, and then 5 plus 4 equals 9. Well, so now I have one equation with one variable that I know how to solve. I can divide by 3 and get that y equals 3. Then, just like with substitution, if I want to find out what x equals, I'm going to plug this into one of these two equations. And it doesn't matter which one, but I'm going to use the top one, because in the top one, x is positive. So I have x plus 2 times y, which was 3, equals 5. Well, 2 times 3 is 6. And when I subtract 6 from both sides to get x by itself, I get that x equals negative 1. So my ordered pair solution is negative 1, 3 for that problem. And so that's what elimination looks like. So look at number 2. If you look at number 2 and you look at your two equations, hopefully you notice that these y's will eliminate. So I have plus y and minus y. So when I add these two together, my y's cancel, which is what I need something like that to occur so that I can add up everything else and have one equation, one variable. So this becomes 3x equals 6. And I can divide both sides by 3 to get x equals 2. And then I can plug that back in. And just like before, I'm going to use the top equation, because in the bottom equation the y has a minus sign in front of it. I want a positive y. It makes my life easier. So I have 2 times 2 plus y equals 5. Well, that makes 4 plus y equals 5. And when I subtract 4 from both sides, I get that y equals 1. So my ordered pair solution for this problem is 2, 1. Now, if you look at example number 3 is very similar, but if you pay attention to how it is set up, my stuff isn't lined up. I have 4x over 3y, and then I have negative 3y over negative 4x, and nothing lines up. So the first thing I'm going to do is line everything up. So I'm going to rewrite this. I'm going to leave the top equation alone, 4x minus 3y equals 12. But then the bottom equation, I'm going to switch the order of these two because I want the x's to line up. This minus sign in front has to come with it, so it's negative 4x. This was positive, so it's plus 3y equals negative 12. Now everything lines up. You want things to line up. It makes things easy. And when I add these two equations together, you should see that the x's cancel because they have the same number but they're opposite. The y's cancel because they're equal but opposite. But my constants over here also cancel because they're equal but opposite, leaving me with 0 equals 0. And that is a true statement. 0 really does equal 0. And so when this happens, what you have is infinite solutions. These two lines, or these two equations, would make the same line when I graphed them. And so they graph one on top of the other. So they intersect everywhere. So there's infinite solutions. Now, if I had a problem like this, 2x plus 3y equals 6, and x minus, negative 2x minus 3y equals 8, and I add these two together, the x's cancel and my y's cancel, but I'm still left with what this is when it adds up. That makes 14. So I have nothing over here but 14 over here, and this is not true. And when that happens, then you have no solution. So everything cancels, makes infinite solutions. All the variables cancel, but constants don't. You have no solution. So let's do one more example. We have a word problem here. about David and Jose. They went to Target to buy some clothes. David bought 2 shirts and 1 pair of jeans for $53.50. Jose bought 2 shirts and 3 pairs of jeans for $108.50. We want to know how much is 1 pair of jeans. Well, we got to set up variables first. So we're going to do our let statements. We're going to let S equals shirts. For the record, I do not like to use the letter S as a variable. It looks too much like a 5 sometimes, and I've seen too many mistakes with people writing an S but thinking it was a 5. So we might pick something different next time. And then I'm going to let P equal pants because I got shirts and pants. I could do J for jeans as well if you wanted to, but I got shirts and pants. So David bought 2 shirts and 1 pair of pants for $53.50. Jose bought 2 shirts and 3 pairs of pants for $108.50. I want to know how much 1 pair of pants is, so I'm looking for P. Well, I need to eliminate something before I can do anything. And if you look at the problem that I have, nothing automatically eliminates. I got a 2S and a 2S, but they're the same sign. If I add these up, it's just going to make more S's. I need one of these to have the opposite sign. The only way to do that is to take one of my equations, and it doesn't matter which one. I'm going to do the top one and multiply it by -1. That 1 will keep the value of everything the same, but the negative will change all the signs. So it will make it so that I have -2s minus P equals -53.50. And then the bottom equation I didn't do anything with, so I'm going to just bring it down. You always want to bring it down because you want to line up the things that you are adding together. So now I can add those up. Now my S's cancel. And so I have -P plus 3P makes 2P. And when I do -53.50 plus 108.50, it comes out to be 55. And then when I solve for P by dividing by 2, I get that P equals 27.50. And so 1 pair of pants, which is what they were asking for, is $27.50. So if you look at a problem and nothing eliminates right away, but you have something that does have the same coefficient in front, multiply one of them by -1 to make it cancel. So that's elimination day 1. Simple, basic, straightforward. Find a variable that eliminates, eliminate it, add up what's left, and solve for that variable. Then plug it back in to find the other variable. Please make sure you're always finding both variables unless it's like question number 4 here and they only ask for one of them specifically. If it just says solve, you have to find both. So we'll practice this tomorrow. Don't forget the substitution day 2 homework, the one about the Disney movie and the stupid boyfriend, is extra credit. If you do it, have it tomorrow. So I will see you then. Have a good rest of your evening.